for our session today, we will be having the remainder theorem and the factor theorem. Now, to begin with, let's have a review first on how to evaluate functions. Like, for example, you are given a function of x wherein it is equal to 4x cubed plus 3x minus 5. And we will be finding the value of this function when our x is equal to 2. So what we will be doing here is simply you substitute 2 over the x's there. So the x there will be replaced by the number 2, which is our value in our problem number 1. So the x here becomes 2. The x here becomes the number 2. Again, you substitute whatever is the value of your function. Whatever the value of your x there, you substitute that to your function. And then you follow the PEMDAS rule. So I'm going to be starting first with the exponent. So I'm going to simplify 2 cubed. That will give me 8. 2 cubed again is 8. Then after which I'm going to do multiplication. So 4 times 8, that's 32. 3 times 6, 3 times 2, that's 6. And then adding from left to right and also subtracting, I will be getting 33 for this one. So the value of our function when x is equal to 2 is simply 33. Let's have another example. If you're given a function of x that is equal to 2x squared plus 7x minus 20, and the value is simply look for the value of the function when x is equal to negative 5. So just like what we did on our previous example, we will be substituting negative 5 to x. So x here will become negative 5. X here will become negative 5. And then you follow the PEMDAS rule starting with the exponent. So negative 5 squared, that's equal to 25. Then you multiply these and these, you will be getting 50 minus 35 minus 20. So adding and subtracting from left to right, you will be getting negative 5 for that. So the value of our function when x is equal to negative 5 is simply negative 5. Let's have another example. What if you're given a function of x that is 3x cubed minus 5x squared plus 4x minus 5? And we will be getting or finding the value of the function of negative 3. So take note, this is the value of our x. So to solve this, we have f of negative 3 that is equal to 3. So the first term, you substitute negative 3 over x cubed. You write the second term, minus 5. Then you substitute negative 3 over x squared plus the fourth term, the third term I mean, that's 4 times negative 3 minus 5. And just like what we did a while ago, you start with the exponents first. So when I have this one, negative 3 cubed, that's negative 27. Minus 5, then I have negative 3 squared. This will give me 9. Plus 4 times negative 3 minus 5. Then proceed to multiplication. So we have negative 81 for 3 times negative 27. 5 times 9, that is negative 45. 4 times negative 3, that's negative 12, minus 5. So performing addition and subtraction from left to right. So we have negative 81 minus 45 minus 12 minus 5. We will be getting negative 143 for this. So this is the answer for our third problem. So this is how we evaluate functions. And we will be using this concept later on as we go on with our lesson today. Now, let's proceed to the first theorem. We call the first theorem the remainder theorem. And it states, if a polynomial f of x is divided by x minus a, the remainder is a constant f of a. And you write this manner. You have there f of x, which is your polynomial, that is equal to the quotient q of x, and multiply that by the divisor, that's x minus a, and this will be our remainder f of a. So it's simply dividend equals quotient times divisor plus the remainder. Now, to further expound this and to discuss this, let's have our first example. Let's get the remainder of 5x squared minus 4x plus 3 divided by x minus 3. So let's do this using synthetic division. So using synthetic division, we are given 5x squared minus 4x plus 3. And take note, these are our coefficients and the value of a. So the value of a, this one came from our divisor. Okay? And then the coefficients, you have 5, negative 4, and 3. 5, negative 4, and 3. So you'll be having bring down 5 because we will be using synthetic division. Then multiply 3 and 5 to get 15. Combining negative 4 and 15, you'll get 11. Multiplying 3 and 11, you will be getting 33 for that. Combining 3 and 33, that is 36. This one is what you call your remainder. Now, there is another way of getting the remainder, and we will be using the concept of evaluating. Okay? We will be using the concept of evaluating. Like, for example, we have this one. I want to find the value of the function where x is equal to 3. Now, sir, where did you get this value over here? I got that over the divisor. It's very similar with our synthetic. So this one is simply the value of x. So f of the opposite of negative 3 is positive 3. So that will be the value of x na atong i-evaluate. So you substitute. So this becomes 3. This becomes 3. Then you do the exponent. We have 3 squared, that's equal to 9. Then multiply 5 and 9 to get 45. 3 and 4 to get 12. And adding from left to right, that will be 36. And take note, it's the same as our result in synthetic division. Now, take note also, when I evaluate a function and when I divide the function using synthetic, the remainders are totally the same. Again, the remainders are totally the same. So it's up to you whether you will be using synthetic division or evaluating a function. Let's have more examples. Example number 2 for the remainder theorem. So let's make use of synthetic division first. So the value of a based on the divisor, it's 4. And then the coefficients, x raised to 4, that's 5. X cubed, that's negative 13. X squared, that's negative 14. For the value of x, that's negative 47 coefficient. And the constant term, which is 1. So I am simply writing the coefficients of each term. Then, let's do synthetic division. Bring down 5. Multiply 4 and 5 to get 20. Combine negative 13 and 20. That will give us 7. Multiply 4 and 7. That will give us 28. Combine negative 14 and 28. That's positive 14. Multiply 3, another 4 and 14. That is 56. Combine negative 47 and positive 56. That would be 9. Multiply 4 and 9. That will give us 36. The remainder is the number 37. Now, sir, are you sure that it's 37? Let's make use of the other method now. So we have a function wherein the value of x, the opposite of negative 4, is positive 4. Let's start with the first term over here. So 5, then you substitute x, which is 4 raised to 4. Minus, let's go to the next term, 13, substitute x, this becomes 4 cube, minus 14, then you substitute x, that is 4 squared, minus 47 times 4 plus 1. Okay? Now, let's do the exponents first. So, 5, multiply that. What is 4 raised to 4? That is right, 256. Minus 13, multiply that by, what is 4 cube? 4 cube, that will give us 64. That's correct. Minus 14, what is 4 squared? 4 squared, that is 16. Minus 47 times 4 plus 1. Now, let us multiply. We will have 5 times 256. That will give us 1,280. Minus 13 times 64. That will give us this one. This will give us 832. Minus 14 times 16 will give us 224. Minus, we have 47 times 4. That will give us 888 plus 1. Now, let's do addition from left to right, including subtraction. 1,280 minus 832 minus 224 minus 888 plus 1. You will get 37, which is totally the same with our result when we did synthetic division. Now, it's up to you whether you'll use synthetic or you'll use evaluating a function to get its remainder. Again, let's go to the next item. So we have here, let's go to synthetic division first. So the value of A is -2, the opposite of +2. Then the coefficients are the number 10, the number 5, the number 20, and the number -7. Let us now do synthetic. Bring down 10, multiply -2 and 10, that's -20. Combine 5 and -20, that's -15. Multiply -2 and -15, that is 30. Combine 20 and 30, that's 50. Multiply -2 and 50, that's -100. Combine -7 and -100, that's -107. This will be our remainder. Now, let's verify this using evaluating a function. So we have f of -2, that's right. Let's do the first term. So 10 times -2 cubed, the second term, plus 5 times -2 squared, plus we have the third term, 20 times -2 minus 7, which is our last term. Again, we will start with the exponents first. So 10, what is -2 cubed? That's -8. Plus 5, then -2 squared, that's +4. Plus 20 times -2 minus 7. So we have multiplying these two, -80, plus multiplying this, you'll get 20. You multiply this, or that is positive. No, that's not positive. That's negative. That is -40. That's -40. So this one, -40 na siya, minus 7. And when you add all these numbers, you will be getting -107, which is the same as our result when we did synthetic division. That is all about the remainder theorem. Now, let's proceed to the factor theorem. The binomial x minus a is a factor of the polynomial f of x if and only if f of a is 0. So I'm gonna reiterate this. I'm gonna rephrase this. So if your divisor, you will have a divisor x minus a, x minus a is a divisor, and it is a factor of your polynomial f of x if the remainder is 0. Again, if mag-synthetic ta using the divisor and the remainder is 0, then it is a factor. Let's have an example on that. We have here x cubed plus 4x squared minus 15x minus 18 all over x minus 3. Is x minus 3 a factor of x cubed plus 4x squared minus 15x minus 18? Now, to solve this, let's make use of synthetic division. So there you go. Those are our coefficient. Starting off with the value of a, which came from here. Then we have the coefficient of x cubed, 1. The coefficient of x squared, 4. The coefficient of x, that's negative 15. The coefficient of the constant term, that's negative 18. Bring down 1. Multiply 3 and 1 to get 3. Then you combine 4 and 3, that's 7. Multiply 3 and 7, that's 21. Combine negative 15 and 21, that will be 6. Multiply 3 and 6, that's 18. You will get a 0 for that. So therefore, since the remainder is 0, our divisor x minus 3 is a factor of the polynomial x cubed plus 4x squared minus 15x minus 18. Now, based on this, I can get the other factors as well. And how do we do that? We can use factoring in this case. Now, take note. We will be using factoring if we have 1, 2, 3 numbers left and the 0 remainder. Again, 1, 2, 3, and a 0 remainder. We will be using factoring for that. Okay? In case that there will be 4 numbers followed by a 0, that will be for another tutorial video. Now, let's proceed now. So we now have, this is x squared. That's totally right. Diba? I'm gonna be writing this as an expression based on synthetic division. We have x cubed minus 1. This will be x squared. Next will be plus 7x plus 6. Now, diba? The sign of the factors when your trinomial is plus plus is also plus plus. You will be writing x here and x over here. Now, what are factors of 6? When added, it will give us 7. Very good. It's 6 times 1. I cannot use 3 and 2 because if I'm going to add 3 and 2, it's 5. And 5 isn't the middle term. I'm looking for a sum of 7. So I'll be using 6 and 1. So I'll be writing 6 over here and 1 over here. And therefore, the factors of x cubed plus 4x squared minus 15x minus 18 are simply our divisor a while ago, x minus 3, x plus 6, and x plus 1. Okay, now let's have more examples. Example number 2. So we have here a given polynomial, and let's verify whether this is one of the factors. And later on, let's get the remaining factors. So to do this, we have now, let's do synthetic. This is positive 8, very good. Then we have the coefficients. We have 1 for x cubed, negative 11 for x squared, 14 for x, and 80 for the constant term. Let's do synthetic now. Bring down 1. Multiply 8 and 1. That's 8. Combine negative 11 and 8. Negative 3. Multiply 8 and negative 3. That's negative 24. And you have 14 and negative 24. That's negative 10. 8 and negative 10. That's negative 80. Thus giving us a 0 remainder. Therefore, this is a factor. To further find the other factors, so 1, 2, 3, I can now make this as an expression. So this is now x squared minus 3x minus 10. And doing factoring, given that it's negative, negative, the factors will be plus and minus. Writing x on both factors. What are factors of 10? When subtracted, it will give us 3. Very good. 5 times 2. Because 5 times 2 is 10, and subtracting 5 and 2, you will get 3 for that. Now, which should be negative? Very good. The number 5, because the bigger factor will carry the sign of the middle term. Maunang negative 5, positive si 2. Therefore, our factors are x minus 8. There you go. X minus 5. There you go. And x plus 2. There you go. Now, sir, are you sure that x plus 2 and x minus 5 are really factors of the polynomial? Okay. To check whether they are both factors, let's use synthetic over them. So let's begin first with x plus 2. If I'm going to have x plus 2 as my divisor, the value of a is negative 2. That's totally right. And we have the same coefficients. We have 1, negative 11, 14, and 18. Okay, let's do synthetic. Bring down 1, multiply, that's negative 2. Combine, negative 13. Multiply, that's 26. Combine, that's 40. Multiply, that's negative 80. You will get a 0 remainder for that. Okay, so therefore, x plus 2 is a factor because this is already checked. Let's go, sir. What about negative x minus 5? So I will be having positive 5 for the value of a. Still, the coefficients are the same. And let's do synthetic division. So we have bring down 1, multiply 5 and 1, that's 5. Combine, that's negative 6. Multiply, that's 30 negative. Combine, this is negative 16. Multiply, that's negative 80, and a remainder of 0. Therefore, x minus 5 is also a factor. Now, sir, do we need to show the checking part? No, you don't need to show this anymore if you are very sure that your factors are all correct. Let's go to our last example for our discussion today. So we have 2x cubed plus 7x squared minus 33 minus 18. And the divisor is x plus 6. So, using synthetic, it's negative 6 for a. First, 2. Second, we have 7. Negative 33. And negative 18. Let's do synthetic now. Bring down 2. Multiply negative 6 and 2. That's negative 12. Combining this is negative 5. Multiply that. That's 30. And combining this is negative 3. Multiply that. That's positive 18. And a remainder of 0. Therefore, this is already a factor. Let's get the other factors. To do that, so we will have 2x squared, since we have x cubed minus 2, that's x squared, minus 5x minus 3. To do factoring, let me have that on the other side. You still remember this method, like you will be having a number over x squared. Diba the first step is to determine the sign first. So this is negative, negative. The sign will be plus, minus. Diba you will be writing 2x over 2. And you multiply 2 and 3 to get 6. What are factors of 6? When subtracted, it's 5. Sir, 3 and 2? No, because if you'll subtract 3 and 2, it's 1. I am looking for a difference of 5. Yes, that's right. 6 times 1, because 6 times 1 is 6. And when you subtract 6 and 1, it will give you the middle term, which is 5. Now, which should be negative? The bigger factor, sir. Which is the bigger factor? 6. So, 6 should be negative, positive si 1. Then, you do factoring. Since wala ni siya common factor, bring it down. 2x plus 1. Over here, what's common? The number 2. So, we have x minus 3 all over 2. Cancel this out. So, our factors are x, 2x plus 1, and x minus 3. These are your factors. X plus 6, 2x plus 1, x minus 3. And that ends our discussion about the remainder and the factor theorem. Till my next video, guys. Bye.